This lesson 1.1, we start out with definitions. What are counting numbers? You're a little bitty kid. 1, 2, 3, 4, 1 little, 2 little, 3 little, Indians, whatever. Let's see, what else did we do? One candy bar. Two candy bars. Remember Dracula? Count Dracula. No? Nobody watched that? I love the count. All right, so natural numbers are also called counting numbers, and you start with 1 and go on forever. What are whole numbers? 0, 1, 2, 3. What are the integer numbers?
-3, -2, -1, 0, 1, 2.
Okay, so we still have not dealt with any decimals, no fractions. So a lot of people assume that a whole number means not a decimal or a fraction, right? And that is technically not true in math. In math, we say the whole numbers start with 0 and go forward only the positive numbers. When you introduce the negative numbers, then they are all of the numbers you had before from the set above it. And each one of these are called a set, by the way. It's like you have a bowl and you have the nested bowls at your house. So you've got your mom's mixing bowls and she's got a big bowl and then she's got a little bowl and a little bowl. The natural numbers are the smallest set of numbers. And so we added 1 and got the whole numbers. Then we added all of the opposites or negatives and got a bigger set. So then what is the root word of rational? Who are my English people? Ratio. What is a ratio? It is a fraction. It's also any decimal that can be written as a fraction. So what kind of decimals can be written as fractions? Now, some of you gave me some examples. 1/2. So that decimal was a 0.5. A decimal that terminates or stops can be written as a fraction. What about repeated decimals? 0.3 repeating, 0.6 repeating. They can be written as a fraction. So the decimals that repeat and the decimals that stop are rational numbers, and all of the ones that were falling. How do you write -3 as a fraction? -3 over 1. 0 over 1. 2 over 1. So all of the numbers that were previous plus all of those decimals that stop and repeat. All right, English people, what is the root, the suffix, rather, IR? Not suffix, prefix, right? Prefix, because it comes in front, pre.
Not rational.
Not. Yeah. The ones that are rational numbers are the decimals that stop and repeat. So which ones do not stop or repeat?
Continuous.
The ones that do not repeat but are continuous. So numbers like pi, they go on and on, but there's no repetition. Okay, so pi is probably the best one. And then we have real numbers. Pi never stops. It goes on forever. Now with calculators, like they still keep going.
We had a whole conversation about this because we were like, pi never stops, but like numbers never, like series never repeat. Wouldn't that mean at some point they stop?
There's an infinite number of combinations.
We had a long conversation about this.
I love the in-depth of that conversation.
If it stretches on infinitely long, then there's an infinite amount of extended combination of numbers.
That's a problem.
That's what I said.
Nice.
We want to work on 9, so 9.
All right. What are real numbers? What are real numbers?
Is this the biggest set?
Not imaginary numbers.
They're not imaginary. So everything that we just did, all of those are real numbers. Now, if you're looking at the idea of a set of numbers, and we have, here's our bulletin board, because you know I'm a teacher. So here's the bulletin board, and it has the real numbers. Over here we have the irrational numbers, and over here we have the rational numbers. And inside the rational numbers, we have the integers, the whole numbers, and the counting numbers.
That's a great graph. I love that.
Okay.
Sounds like a stove.
It kind of does look like a stove.
Oh, nice. Nice. I was going with bulletin board, but stove it is. There you go. All of these numbers are real numbers, which tells you that we are not dealing with those imaginary numbers yet. Okay? We're not dealing with them yet. Now, on page 8 of the textbook, problem number 2 is this, and it says, the instructions say, for all of these elements, which ones belong to A, the natural numbers? Which one of these are natural numbers? 8 and nothing else, because natural numbers were the counting ones. Think, what would a 4-year-old say? Which one of those are numbers? And they would say 8, right? Because that's the only one they know. Which one of those are whole numbers?
0, 0,
Integers, rational numbers.
Oh.
Can I write -8, 0, and 8 as a fraction?
Yes.
So -8, 0, and 8 still count. And now I'm going to just go in order from left to right. What is a -14 divided by 7? Is that rational? -2 or 0.245.
Yeah.
Why? Because it stops. Yeah, it's a decimal that stops. We have the 0. What's 6 divided by 2?
3.
We have the 8. What is the square root of 81?
9.
9.
Now, what is the square root of 12?
Something that's irrational.
2 root 3. Square root of 3 is irrational. How do you know that? Because
It goes on.
if you type it in the calculator, the square root of 12 is a decimal that does not repeat, but keeps going. So irrational is square root 12. Which one of those are the real numbers?
All of them.
Yeah, all of them. And I'm okay if you write all. You don't have to write the whole list.